Okay, we're getting into the discussion of surface area of composite solids. Okay, so we're continuing on with the discussions of composite solids. So this will be a little bit of the same, but as you're going to see, working with surface area, it's a little bit of a different ball game. Okay, volume was very much cookie cutter, very cut and dried, kind of easy to understand. Surface area, there's some more things to consider when it comes down to surface area, and we'll get into that more in here in just a second. When calculating surface areas of composite solids, the same ideas we use with volumes will still apply. What we'll see is that there are some new considerations, and you may have already seen some of these things, or maybe have at least thought about them in the back of your mind a little bit, and we'll get to them in great depth. These are the 5 solids that we did when we were going through volume. So if you've got them copied down, that's great. We did change some of the values on some of these measurements because, quite frankly, the variables that are needed in order to calculate volume are not necessarily the same variables that are needed to calculate surface area. Okay, so let's take a look at the first figure. I'll give you a moment to scribble it down and its measurements, and then we'll see if we can figure out what we need to know in order to calculate the surface area. Okay, now how did we describe this shape when we were talking about volume? Okay, what is this thing? Okay, this was the basic description that we came up with when we were working on volume. I'm going to tell you right here and right now that there is something, at least one thing, significantly wrong with describing this in the idea of surface area as a prism plus a pyramid. Okay, take a moment and examine this thing, and let's see if we can figure out what's wrong with this idea as far as calling this surface area is a prism plus a pyramid. Okay, when we talk about surface area, okay, what does surface area actually represent? All of the material that it takes to cover the figure, okay, everything that's on the exterior. Okay, we've got a problem with thinking of it like that. Okay, because look at the prism. Okay, prism has 6 sides. Are all 6 of these sides on the exterior of the figure? No, one of them has been covered up by the fact that a pyramid was added to the figure. Okay, and we've got the exact same problem going on with the pyramid. Okay, the pyramid has 4 triangular lateral faces. It also has a base, but the base is not on the surface of the composite solid anymore. So if we include those locations as part of the surface area, then we're actually including faces that are no longer even on the surface. So our surface area calculations will not come out correct. So what we're going to have to do when it comes down to surface area of composite solids is we're going to have to make some verbal adjustments to what is actually there. And then that's going to put us in a spot where we're going to have to make some adjustments to the formulas that we're going to pull off of the formula chart. We'll get to that here in just a second. Okay, so if we wanted to start off with the prism, yeah, okay, prism. Now, did we get the entire prism? No, we don't get the entire prism in this case. Okay, now we've got 2 different formulas. We've got a total surface area formula, and we have a lateral surface area formula. Unfortunately, I don't think that this prism fits into either of those formulas, because if you only pick the lateral surface area formula, then you're not going to get either one of the bases. If you pick the total surface area formula, that gets both of the bases. We're actually only needing one base. So probably the easiest way to think about this one right now would say, hey, it's a prism minus one of its bases. It's got one of them, but it doesn't have the other one. Okay, and the reason it doesn't have it again is because it's caught in between itself and the pyramid. Okay. Now, to that information about the prism, we also need to add in information about the pyramid. Okay. But again, let's consider this pyramid. Do we have the entire pyramid as far as surface area is concerned? Yeah, it's a pyramid missing a base. Okay, but here's a little bit of an interesting point on that language. How many bases does a pyramid have? It's only got one, and it's missing it. Okay, so do we really need to use a formula that includes the base and then take the base back off of it? No, that wouldn't make any sense. So what we'll want to do is we'll want to pick a formula that doesn't do total surface area, but instead does lateral surface area. That's right. Okay, so when we go to get this formula, we'll make sure that we get the pyramid with the lateral surface area rather than the total surface area. Okay, so these are a little bit strange as far as formulas go. We haven't really run into anything like this. Okay, but let's see if we can turn this explanation into a formula, and then we'll turn the formula into some numbers. Okay, how do you find the surface area of a prism? Yep, big B, little h. Oh, I'm sorry, that's incorrect. Yep, P, H, and what? Plus 2B. Okay, good. Yeah. Now, that's what Erica said is exactly right. We got pH plus 2B, but then we're going to take away one of the bases. So she said 2B minus 1B, or let's simplify that thinking even further, and let's say, you know what? The formula calls for the area of both bases. We don't want both bases. We want one base. So what we could really do is right there in the formula, change it to a single B rather than two B's. Okay, and that's kind of an interesting situation. That's putting us in a spot where we've never been before. Everything we've ever done in mathematics has come with a formula, and we are told, here is the formula. When you have this problem, you take the formula, you plug your numbers in, and whatever the formula says, that's what the answer is. Guys, when it comes down to composite solids, you may be forced to adjust your formulas according to what your problem is doing. Okay, that's new for us. Okay, but anyway, there is your information about your prism, plus what do you know about finding the lateral surface area of a pyramid? Okay, 1/2 PL, that's all. Okay, yeah, there's a formula on there that has the plus B. Do we want the one that has the plus B? Now that would be the total surface area, including the base, and we've already decided that we do not have a base to include, so there's no reason to use that formula. Okay, so let's fill in some numbers. Okay, P represents the perimeter of your base. Okay, so in these red parentheses here, perimeter of our prism. Okay, the perimeter of the base of our prism. Okay, what is the perimeter of the base of our prism? No, not 36. We're not getting the area. We're just going around the outside. So 6 yards across the front, 6 yards across the right, 6 yards across the back, 6 yards across the left. Okay, you've got 6 on each side and 4 sides, right? 24. Okay. What about the height of our prism? Okay, 7 yards. Okay, that gets added to now the area of the base. Okay, how do you find the area of your base? Okay, length times width, which in a squares case is the same value twice. 6 squared. Okay, continuing on. That needs to be added to, what do we have? 1/2 is built into the formula, so there it is. Okay, again, P is the perimeter of the base of your object. Well, this time the object is the pyramid. Okay, what about the perimeter of the pyramid? And it's going to be the same as the perimeter of the prism, right? Because the pyramid and the prism basically share the same dimensions as far as their bases go. And what's L represent? Yeah, that's your lateral height, okay, your lateral height. And remember, that is your measurement coming from the vertex of your figure down one of the lateral faces, okay, right in there. So we do not have that guy. Okay, so since we don't have it, our typical thing is to construct a triangle inside of there and try to go from that. Okay, so what measurements do we have? Do we know this overall height inside of that pyramid? It is 4. How'd you come up with that 4? That's right. You've got 7 yards worth of height that are used by the pyramid, 11 yards of total height for the entire composite figure. So that must be 4 yards left over for the height up there. How about the apothem inside the base of that pyramid? It is 3. If it's 6 units all the way across, then the apothem would be 3 coming across there. You've got 2 sides of a right triangle. We can very easily calculate the third side or the lateral height of that triangle. Does anybody know offhand what it's going to be? It's a 5. Why is it a 5? Yeah, it's a 3, 4, 5. This is one of those, what's that term called? Pythagorean triple, exactly. And if you couldn't spot that, that's fine. You can still go 3 squared plus 4 squared equals the lateral height squared. Solve it from there. And in either case, you will end up with a lateral height of 5. Okay. From here, all we really need to do, I mean, you've got the formula all converted to numbers. Yeah, we're just going to go to the calculator and we're going to figure out what these values are. We should be able to do this really no problem since there's nothing fancy. We've got 24 times 7, which is then added to 36. Okay, and that is also added to half of what? 6 times 4 is 24 times 5. Okay, and assuming I haven't typoed anything, okay, looks like we've got 264 something. 264 what? Yards? What dimension? Yeah, area is second dimension. Volume is third dimension. Area is second dimension. Okay, so 264 square yards. Okay, this is the way these problems are going to work. You're going to have to evaluate what is happening in the problem, select the formulas that are as close as you can get them, and then adjust the formulas to match what is actually happening in the problem. Let's look at the next one. Okay, as people are already figuring out, this shape is a cylinder and a cone. Okay, very clear to see that. We just need to figure out that when it comes down to surface area, if we can call it a cylinder and a cone, or if we're going to have to make any any adjustments to the formulas. Okay, cylinder. Is it an entire cylinder? It is not. Okay, so what are we going to have to do to it? Yeah, we're going to have to take a base away from it and possibly spell the word cylinder correctly would be nice as well. Okay, it's a cylinder, but it's not an entire cylinder. It is missing one of its bases by the fact that the cone is covering it up. Okay, so cylinder minus base and cone. Okay, do we get the entire cone this time? No, we don't get the entire cone this time. What's it missing? It's missing a base. Well, it only had one base to begin with, so there's no need to pick a formula that includes the base. So we will pick on the formula that just uses the lateral surface area. All right, let's see if we can convert this sentence into something mathematical. How do we find the surface area of a cylinder? Okay, well, total, because we're still including the bases. Okay, there's a couple of formulas that are provided for you on the formula chart. I don't particularly care for either one of them. Okay, but out of the two of them, the first one is the better. If you'll remember, the formula that I gave you for the surface area, or the surface area of I'm sorry, the cylinders. Okay, I treat them just like prisms. Okay, I call them prisms. They just happen to have circular bases. But anyway, the formula for surface area says 2 pi RH plus 2 pi R squared. Now, before we get away from this, I want to stop and discuss what this thing actually says. okay, because this is a different formula than probably you have seen yet. Okay, 2 pi r right there. What is that? What does 2 pi r represent? What about the base? Not the area. Circumference. It's circumference, okay? That's one revolution around the perimeter of a circle, 2 pi r. Okay? Now what's h represent? Height of what? Height of the overall shape. Yeah. Okay, so let's think about what that actually says. Okay, what did we just calculate there? 2 pi r is the distance to travel around the circular base. Height is the distance between the circular bases. Well, when you unfold a cylinder, okay, 2 pi r times height, that's the rectangle that wraps around the circular bases. Okay, this is a rectangle. That's base times height. Okay, it just so happens that the base is exactly as long as the circumference. Okay, so that's the rectangle. And over here, what's this? Pi r squared. That's an area of a base. And of course, the formula announces that there's two of them. Okay, now coming back to the problem at hand, okay, this is the cylinder, 2 pi rh plus 2 pi r squared, and we said that we would be minus a base. So do we need 2 pi r squareds? We do not. We only need 1 pi r squared. So we're going to take one of those away. Okay, that is your cylinder. And to that, we need to add the lateral surface area of the cone. And how do you find the lateral surface area of a cone? Probably a funny formula that you've never seen before. Yeah, pi r l. Okay, kind of a strange little formula, but that's what it is. All right. Now let's just plug in. This one is not as nearly as bad as it looks. 2 is 2. Pi is pi. What is radius? Okay, the radius is 3 this time. Height is 2. Okay, just the height of the cylinder. Plus pi is still pi. Radius is still 3. Plus pi is still pi. Radius is still 3. What's L? So lateral height of our cone. Okay, let's take a peek at the problem. There's lateral height. Okay, it's obviously not provided in the problem. Okay, so if we go to build a triangle, okay, let's see what we have. Okay, do you know any of the other measurements? Yeah, 3 come in that direction because of the radius. Yeah, and also 3 on the height of the pyramid. Again, you got 5 feet across your total height of your composite solid. 2 of those feet are used up by the cylinder, leaving 3 feet for the height of the pyramid. Okay, can you find lateral height now? We got 2 sides of a right triangle. They happen to be 3s, both of them. Lateral height squared. That's 9 plus 9 equals lateral height squared. That's 18 equals lateral height squared. And when you take the square root of both sides, you get the square root of 18. Okay, so the square root of 18, that is our lateral height. And that was the only thing that was stopping us from finishing off plugging in for the formula. Now, this is a very ugly looking formula, but it's just a bunch of numbers. Okay, so let's just figure this thing out. We got 2 times 2 is 4 times 3 is 12. So that very first term there is 12 pi. That's 37.70. Okay. The next term there is 3 squared, which is 9. And there's a pi in there as well. 9 pi is 28.27. Down there, we've got a whole number 3. We've got an irrational number, square root of 18. And we've got a pi on that one as well. And we got 39.99. And the only thing really to do is to finish combining all these numbers. Well, they're all three there in the screen, so I can use a few extra decimal points there, make sure I didn't round off too badly. And it appears that we have a surface area of 105.96, 105.96 what? Square feet. There it is. Okay, we're getting the basic idea here. All right, now comes the fun. Now, just as the same as there was a little bit of a catch to the way that we thought about composite shapes in the sense that it was two shapes added together, it brings a whole different element of thought to how to deal with composite shape when it's one shape removed from another. Okay. But it's the same basic idea. It's just got a little bit of a twist to it. I'll give you a second to jot it down, and then we'll see if we can work it out. Okay, now from our discussions over the last couple of lessons, or a couple of days, I think we well know that this is a cube missing a rectangular prism, okay, which is fine. Okay, so let's see if we can put this into surface area language. Surface area, uh-oh, I lost my lesson, come back. There we go, surface area equals cube. Okay, do we get the entire cube? It's missing what? Okay, well, just thinking surface area. Okay, just the surface area of the cube. Do we get the entire surface area of the cube? Yeah, okay, we've got all six sides, right? Okay, so we can't just take a whole side away from it like we have been doing, but it's pretty clear to see that we are missing pieces of both the face that's on the bottom of the cube and also the face that's on the top of the cube. And those are just little rectangles. Okay, so that's probably the easiest way to think about this one and say, you know what, I've got a cube, but I've got minus two rectangles, and we'll worry about those rectangles here in a few minutes. Here's where I think people are going to have a little bit of difficulty with this is what happens next. Okay. Well, when it came down to it, if this were a volume question, there was no question that we subtracted. We had a cube that was missing a prism, so we went cube minus prism. But here's the problem. We took a prism out of this thing. Okay, so what does that actually do to surface area? Yeah, and that's where we get to kind of a weird situation. Our instincts would tell us that if you removed a shape, that would make the shape smaller and you would end up with less surface area. But truth be told, by removing that rectangular prism from the middle of the cube, we caused more of the cube to be exposed to the outside than it should have been. Okay, it's like taking an apple. You know, if you take an apple and cut it in half, you still have the shape of the apple, but now you also have the cross section showing on each of the halves that you cut. And that would happen over and over again. If you kept cutting it, you would keep causing more and more and more sides to be showing that shouldn't have been showing. So this is actually going to work the reverse of the way a lot of people are going to think it is. When you remove a shape, it should increase the amount of surface area because there are sides exposed now that shouldn't have been exposed. Okay, so to that cube, we're going to subtract the two little rectangles, but we're going to add what? What's going to get added onto the cube? Yeah, we got some rectangles. Okay, now you got that rectangular prism. Does the entire rectangular prism get added in here? No, what does get added in? We do get the prism, but we don't get the whole prism. Why not? Yeah, this guy right here isn't actually there, nor is the one that's on the top side that's kind of hiding from our vision right now. So we get the prism, but we don't get its bases. So what we want to say is, instead of, all right, I'm going to add on an entire rectangular prism, what we're going to say is, oh, I'm only going to add on the lateral area of the prism, okay, because it doesn't actually have any bases. Those little rectangles on the top and the bottom, they are missing. That's open air going inside of that cube, okay. Now, this is a very long explanation to basically get to this point, okay, surface area. How do you find the surface area of a cube? It's what? Side cubed? That would be volume. Yeah, it's actually, if you hadn't noticed it yet, it's the very first surface area formula that you're provided on there. And that's really one of those formulas that we almost don't even need. A side of your cube is side squared, and there's 6 of them. So 6 side squared. That one's pretty easy. Okay. But we don't want these two rectangles. So we're going to remove 2 times a base times a height. Here in a minute, we'll worry about those values momentarily. And how are we going to find the lateral surface area of a prism? It's on your chart. Have a look. Okay. Okay, pH. Do we want the plus 2b part this time? Plus 2b, that's part of the total surface area. That'll get our bases. Okay, we've already decided, you know, there aren't any bases to this thing. It's just a hole through the middle. We want the 4 lateral walls, lateral sides that are up inside of there, but there's no bases to attach to that. Okay, so we'll do the pH, which is kind of a strange formula for math, but anyway, take it from there. Okay, let's plug in some numbers here. 6 is part of the formula. What's the side of our cube? Okay, we got 7 there. Squared minus 2. Okay, now we need the dimensions of the little rectangular cutouts. How big are they? Yeah, 4 by 3. Okay. And then we go, okay, plus P. P is the perimeter of the base for that particular solid. Okay, so looking at the little prism, what is the perimeter of the base of that prism? 4, 3, 4, 3. That's the perimeter. 2 4s and 2 3s, that's 14. And then that needs to be multiplied by the height of that prism. 7. It travels all the way through that cube. Okay. Well, there we go. We've got our formula converted all the way into number form. Okay, so let's get our calculator and see what we've got here. I bet we can get this all in one equation here. 6 times 7 squared, that's 49. From that, we're going to subtract. 4 by 3 is 12, and 2 of them would be 24. Plus 17 or 14 times 7 is 98. Okay, and assuming I haven't typoed anything, this should be our surface area. 368. Yeah, what was it? Square inches. And there is your surface area. Now we're going to hold off on the last 2 examples for tomorrow. We weren't going to be able to get through all of these examples today anyway, so I didn't want to rush through it because this is it's fairly new and a little bit confusing to some people to think about it. So I wanted to take enough time to get through them all kind of slowly. And we'll finish up the last 2 tomorrow, and that'll give you a little bit of time to begin your assignment tomorrow in class as well.